bit more progress here. This is really good progress because I have all 7 of the vacuum fluorescent displays hooked up. Kind of a lot of logic actually to do that. And I moved the indicator tube over here with its transistor circuit, getting rid of that extra breadboard that I had back there. And I replaced the 5-volt linear regulator here with this switching supply one, which is really cool. It's just like a inline package there. It's the exact same pinout as a linear regulator, but it's significantly more efficient. Linear regulators are like 30% efficient, so most of the voltage is converted to heat, whereas these are like 92% efficient. So they run really cool, and they don't draw nearly as much current. Just replacing that one linear regulator with that switching power supply pretty much dropped my current consumption in half. So we're at 24 volts, and you know, I was over here almost at an amp with that linear regulator in circuit, and pulling it out of circuit and doing a couple other modifications, it's dropped me down to about 380 milliamps, which is significantly less. I mean, that's outstanding actually. So that was a huge win right there. And that sucker is only like $5. Yeah, I bought a few of them for you know, future circuits. So I have a couple of these guys. They're really awesome. They're just a little switching supply here, and they're the exact same pinout as a linear regulator, but way more efficient. Really cool. Anyhow, I do still have one linear regulator in circuit here, which is the 15-volt one here, but that's actually also an upgrade because I did have a 12-volt linear regulator right there, and it's dropping the voltage in half from 24 volts down to 12. And so, you know, even at 40% efficiency, that's still generating quite a bit of heat. And it turns out that that regulator is feeding my 12-volt generator supply over here, which is a 555 timer. And because of the voltage drops on that, feeding 12 volts in, I was only getting about -9 volts out. But switching to a 15-volt linear regulator means I don't have to drop the voltage as far, so it runs a little bit cooler, which it's very cool. Like, I can touch it. I mean, no problem. It's even just barely warm. So it runs way cooler, which means it's drawing less current. And at 15 volts going into the 555 timer, now I'm getting actually -12 volts out, which is really cool because the next part of the circuit, which is going here, requires a -12 volt source. So with that change, the linear regulator change, and even adding more VFDs, I'm drawing less than half the current of what I was before, so that's really amazing. Yeah, and let's see, we'll give it a shot here. Oh, I dialed a little bit too far. I took the finger trigger off of here because I'm taking this guy apart to do some machining on it. So if you dial past the number, it counts a little bit past. So there's 9. There's 9 on the dials, or on the indicators, and they'll properly count down. And even if we dial some other number, 3, we still have our clock right here. So that clock is going away. I mean, the LED is going away, and that clock is going to be feeding the circuit that goes here. And we also still have our in-progress indicators. So while anything is happening on the circuit, our in-progress indicators are still staying on. And just do a 2 here. We get 18. 16 plus 2 is 18. So we have our indicators, we have our clock, and we have our in-progress indicators. And our indicator tube of what you dialed. Last part of the circuit is building what goes here. And that's next.